Unit 5, Lesson 12, and it's actually not a full-blown lesson. It's just like it's bringing together concepts we already know. So at this point, now we know how to solve an inequality using 4 properties: the addition property of inequality, the subtraction property of inequality, the multiplication property of inequality, which says that you can multiply the same thing to both sides, and the equality is true unless you multiply by a negative number. You have to change the direction of the inequality. And then the last property of inequality was division property of inequality. You can divide both sides of the inequality by a number, and it stays true unless you divide by a negative number. Then you have to change the direction of the inequality. So now, this lesson here, lesson 12, is combining those. Now we have to know how to solve two-step inequalities. So just like two-step equations, remember, once we simplified both sides of the equations, we worked backwards PEMDAS, okay? So all the properties, the strategy we use for solving two-step equations, the same, except for with inequalities, you have to make sure you're careful when you flip the sign. So let's take a look at this. Here's the Common Core standard. They expect you to be able to solve these type of inequalities. And so here's the form. So 7th grade, equations and inequalities. 4, and then B. Solve word problems leading to inequalities of the form P times X plus Q is greater than R, and P times X plus Q is less than R, where P, Q, and R are rational numbers, specific rational numbers. So if you look at this two-step inequality here, this is a rational number. Remember, a rational number can be a fraction. It can be a decimal form, okay? And that also includes whole numbers, because we could write a whole number as a fraction too, remember? So fractions are decimals that are terminating, or they're numbers that can be written as fractions. Okay, so we're going to solve this one. So first step, what's the first thing I need to do to solve this inequality? Miranda, yes?
Subtract 6 from both.
Nice, so we're working backwards PEMDAS. So we got to look for add or subtract. We have add 6, so we're going to subtract 6 from both sides. That's the subtraction property of inequality. Are we good? And so notice here I have just 6, the integer, but here I added a 0 in the 10th place. Why did I do that?
10 and 2 plus no decimal.
Right, because we want to line up our decimal, and 6 doesn't have a decimal. We can put a decimal there, put the 0 there, and then what do we get back? What's 10 and 2/10 subtract 6? And I see some people have put away their notebooks. Please open them back up and work these out. This is a really short lesson, but I want you to try. So try to work it out. So Miranda, can you tell me what you got when you subtract that? 4 and 2/10. Very good. And now look, this became 0, and then negative 3 and 5/10 x plus 0 by identity property of addition becomes negative 3 and 5/10 times x. That simplifies to that. It's greater than or equal to 4/10. Now notice, when we add or subtract for inequalities, we don't change the direction of our inequality. Okay, we're only doing that sometimes when we multiply and sometimes when we divide. And we only flip the inequality when it's a negative number that we're multiplying both sides by or dividing both sides by. So what's the next step, Miranda? How do I isolate my variable now?
You have to divide by 3.5.
Not 3.5, negative 3.5. And now, is negative 3.5 positive or negative? Negative. So what do we have to do?
Flip the sign.
I got to flip the inequality. So here's this property of inequality, which we just covered in lesson 11. The division property of inequality, it says that, hey, if we divide both sides by a negative number, we got to change the direction of our inequality. So do you see that we change the direction of our inequality? Okay. So in this step, I'm dividing both sides by negative 3.5, but I'm also changing the direction of my inequality. All right, now the easy step. Now we're going to simplify it. But for practice, I want you guys to divide those numbers. Remember, if you're on the numerator, you're in the house. If you're in the denominator, you're out of the house. So does anybody have an answer for me? Is it a repeating decimal, terminating decimal? Does it have an end to it when you divide it out? Go ahead, Miranda. Why don't you finish it up?
Oh, it doesn't. It stops at 1 and 2 tenths.
Nice. So if you got 1 2/10, you did it exactly like you should. Okay? And it is a negative because we have a positive number divided by a negative number, so it's negative 1 2/10. So Miranda, can you walk me through how do we graph this? What's the graph going to look like? There's my number line.
You have an open circle over negative 1 and 2 tenths.
Okay, so because it's a less than, it's an open circle, and we're at negative 1 2/10. So this would be negative 1, so it's just going to be a little bit to the left of that. And we're going to shade which direction did you say?
To the left.
To the left. Very good. Do you guys see how we got that graph? Are we good? Do you see how this isn't much more challenging than what we just covered? It's just combining things that we've already learned in the past. Okay, any confusion about this problem? Okay, let's go ahead and move on to the next problem then. Here we go. Now sometimes, like I said, it's a rational number, so it can be written as a fraction, it can be written as a decimal. And so this is a little bit of review for you. So go ahead and work this out. And the thinking's all the same. Okay, I'm going to give you one small hint. Actually, I think it's a big hint, but well, let me see. Does anybody have an idea? What's the first step? Jaden.
Subtract one half.
Right.
Both sides.
But before I can subtract 1/2, what do I have to do?
Make like the
Nice. Did you guys hear what he just said? I got to rewrite fractions with the least common denominator. Okay, so do you guys see how I rewrote the equation? Okay, and then now, exactly what Jaden said, now I got to subtract 1/2 from both sides, but I'm not going to subtract 1/2. What am I subtracting? A fraction equivalent to 1/2. What's a fraction equivalent to 1/2? Nicole?
A fraction equivalent to 1/2 is 5/10.
5/10. So I'm going to subtract 5/10 from both sides. You see how we just did that? So you see how everything we've learned so far, it's all coming back. You're using it again and again. And now, we know what 5/10 minus 5/10 is going to be. What's that going to be, class? That becomes a 0. Now this one's a little tricky. I have a positive 2/10 and I have a negative 5/10. Let's just think about integers. If the signs are different, what do we do if the signs are different? We subtract the numbers. So what's 5/10 take away 2/10? So I got 3/10. And what's the sign going to be? Negative, because we take the sign of the larger magnitude. So here's what we got next. Okay, are we on the same page with this step? Okay. So, what happens when I add 0 to something? I just get the same thing back. That's the addition property. That's the identity property of addition. So that's what we got here. Okay, we good with that? Is everybody with me up to this step? Now, the next step, you could think of one or two ways. So I can either do it this way. I multiply by the inverse. Do you guys remember what the inverse is? So the inverse of negative 1/3 is negative 3/1. Inverse where you flip the numerator to the denominator. Do you guys remember that? Or if you don't like that, you could think about it this way. Here's the other way you could think about it. I could rewrite this as the fraction. I can multiply this, and this is what I get. 8/3, 8 over -3. Do you guys see that? So you could think about it either way. They're both correct. Do you guys understand how these are the same? Okay. Now, when I multiply this out, we know what happens over here. What happens over here? Somebody help explain to me. What happens to this side of my inequality? Michaela. These cancel, cross cancel, right? And what am I left with?
You're left with 1 over 1.
Well, no, I got a over 1. Right, these become 1, so, but a times 1 is a, and then 1 times 1 is 1, so a over 1, right?
Which would be a.
Right, and I forgot to mention over here, do you guys see that when I multiplied by a negative 3 over 1, I had to flip my inequality? You guys see that? Okay, so make sure, there's a lot of things going on, but don't forget about that step. Okay, so this becomes a over 1, and then what does this become over here? Remember when we multiply a fraction? That's the easiest thing. Well, first of all, what's the sign of this product going to be? See, that's a -3/10, and that's a -3 over 1, right? So it becomes a positive because when you multiply same signs, you get a positive back. And what's my numerator going to be? Now adding, it's going to be 9, and the denominator is going to be what? 10. So 9/10, and it's a positive 9/10 because a negative times a negative is a positive. And then we got a over 1, and we know that a over 1 is just going to be a. Okay, I lost you somewhere. Where did I lose you at? Where at?
Okay, so you see how at the bottom you did 10 minus 1.
No, that's not 10 minus 1. It's 10 times 1. We're multiplying. Remember when we multiply fractions? We multiply straight across. 10 times 1, 10. 3 times 3, 9. The sign is going to be positive because you have a negative times a negative. Positive. Are we good now?
Yeah.
Is that where you're slipping up too?
Kind of.
Well, tell me where so we can walk you through it.
Where you put the negative sign right in front of the 3.
Right here or right here?
Yeah.
Well, a -3 over 1, you can think about it this way. It's 3, right? This is 3. 3 over 1 is 3, right? 3 divided by 1 is what? 3, right? But it's a -3 over 1 or -3, right? So I can also, but I made this a fraction, so I made it -3 over 1. So it's just different ways to say the same thing. I could say the whole fraction's 1 are negative, or I could say the numerator is a negative and the denominator is a positive. Do you see that they all simplify to -3? Robert?
Why did you multiply?
I multiplied because I have a divided by -3 here, right? That's another way to look at this fraction, times a. It's a divided by -3. So to undo divided by -3, I got to multiply by -3, right? I'm multiplying by -3. Yep.
Where it says multiplication property of inequality,
Mm-hmm.
why did you put not what Alexis said, but the first negative -3 over 1?
Mm-hmm.
Why did you put the negative in front of the 3 and not?
Oh, you're talking about here and instead of in front?
No. Yeah.
So this means the same thing. I'm saying the fraction is equal to a negative number. So 3 divided by 1 is 3, right?
So
It's a -3. And then a -3 divided by 1 is -3 still. So they're just different ways to say the same thing. Yep. Yep. Okay, so did I clear that up?
yeah.
No, you have a question in the back?
Yes. Since it was 1/3, why couldn't we just divide 1/3 by 1/3?
Divide 1/3 by 1/3.
Yeah.
Right, but remember when you divide, you're flipping it and you're multiplying it. So you would end up with this anyway. So what you're saying is correct, and I think we're going back to what Robert said. Why did we divide if we were multiplying? Robert, is that what you're talking about? Remember, if I divided by a -1/3, you would turn it into a multiplication by flipping the -1/3 into 3 over 1. So that you see how all these things are like different ways to approach it and think about it. So your way works. It ends up being a multiplication anyway. Do you understand? Okay? So there's a number of ways to think about this. And that's what's interesting about solving equations, is because now there's more than one way to solve it. We're starting to see that we have a variety of ways to solve equations. Okay? So what you're saying is not incorrect either. Okay, any other questions? All right. Now, what's the graph going to look like? So we know 9/10 looks like this decimal here, right? Which is almost a whole, right? So, Noah, why don't you pick up? What's my graph going to look like?
Alright, so it's gonna be 0.9 first. It's gonna be a close.
This is 1, so it's going to be a little less than that, right?
So it'll be right there.
Uh-huh.
It's gonna be a closed circle going to the right.
Very good. It's going to be closed circle, shaded to the right. Does everybody understand? Okay. Now, that looks like a lot, right? But the individual steps weren't too tough. Let's go ahead and take a look at this next problem. We got a word problem. A music club charges 75 cents per song download, plus a membership fee of $5.70. So Diego can spend at most $15 a month on his song downloads. So write and graph the inequality for the number of songs Diego can download. So this is the example. I'm going to walk you through this one. So first off, each song costs how much? Okay, but we don't know how many songs there are, so we need to have a variable for what we don't know, right? What's the variable going to be? S. I like S because that's the songs we're going to do, how many songs we're going to download. Okay, and S is going to be multiplied by the cost of each song, right? So if I bought 2, it'd be 2 times 75 cents, right? Or 3 and so on. So 75 cents times S, and then, but we can't even buy a song unless what? We got paid to be a part of that to have a membership, and that membership is what? $5.70. So it's 75 cents times S plus our membership fee, and Diego, he can't spend any more than how much? So whatever it is that he spends, it's got to be. When they say at most, think about that. Think about that. If I have at most in my pocket $5, how much do I have in my pocket? How much can I have in my pocket? I can have at most 5. So what's that mean? Can I have $5 in my pocket? Yes. Right. So that means what's my inequality going to be? It's going to be equals in there, right? So he's got to be less than or equal to the $15. So here's what we got. At most, here's what the inequality looks like. Less than or equal to. Do you guys understand that? So right now I'm trying to get you guys to comprehend the question and figure out what are my symbols going to be. Okay, so here's my inequality now. Are we good? Does everybody see where everything comes from? Okay. So the first thing I got to do is solve this inequality. What's the first thing I need to do? Somebody tell me. Somebody I haven't heard from. Alexia. Nice. I'm going to subtract 570, but you know what I need to do? I'm going to fix the equation on top a little bit. Watch what I do. Do you see what I just did? Why did I do that? Because we got to subtract, and I want you guys writing this way so we can work it out as we go. So when I subtract this, you guys go ahead and subtract it, and then when somebody's got the result, tell me what the result's going to be when I subtract that. Work it out. Work it out. You guys are trying to mentally do it. Work it out. Write it on your paper. You need these in your notes. And you need the practice too. So next year, your 8th grade teacher is not teaching you 6th and 7th grade things. They're teaching you 8th grade things. Gabby, what did you get when you took $5.70 away from 50? 15. What'd you get? $9.30. I dropped off a 0. I put 9.3, but that's still $9.30. Okay, and then now this came down. This became a 0. And then identity property of addition says that this is just going to be this, right? So is everybody with me to that step? Are we good up to this point? Now, how am I going to figure out how many songs I can download? How do I isolate S? Nemo, how am I going to isolate my S? That's S right there. So we're going to divide. What are we going to divide by? 75 cents. So here we go. There's my division. And did I need to flip my sign? Did I need to? No, why not?
Because it's not negative.
It's not a negative. That's a positive number divided by. Okay, I'm just going to go ahead and walk you through this. 9 3/10 divided by 75 hundredths. This is what we get back. Now listen, they're not going to charge you if you didn't download an entire song. That sometimes happens. Your connection's lost or whatever. If you didn't get the full song, they're not going to charge you. So, 12 songs or less. If he downloads four-tenths of a song, that's not a full song, and they're not going to charge you. So, if he goes over that into 13 songs, then he's over budget. He spent too much. Okay, we good? Now this problem is very similar. This next problem right here, I'm going to read it to you. Let's see if you guys can figure this out. A phone plan charges 20 cents per text message, plus a monthly fee of $42.50. Lynn can spend at most $50. Write inequality for the number of text messages Lynn can send. Graph and describe the solution. So you guys know, just to have your phone costs, it's not cheap just to have your phone. But then, I don't know if they're getting rid of this now, but cell phone companies used to charge you for every text message you sent. You only had but so many text messages you could send. I think they let you send maybe 50, and then you had to pay for each after that. They said 50 a month. I can't remember. But they're always changing the way they charge you. Okay, so who can walk me through this? It's very similar to the last problem. Jaden, go ahead. Walk me through this. Yeah, what'd you use here, variable, first of all? T, and that represents what?
Text.
How many text messages? Okay. So walk me through. What do you think pull from the word phrases up here. What do we have?
So we have 20 cents,
Uh-huh.
which is per text message.
So what's the operation between 20 cents and my text messages?
Multiplication.
So we're going to multiply 20 times T, right? And then what?
We're going to add $42.50.
Okay, that's the monthly fee. So to even have your cell phone, you have to pay $42.50. That's before you even start sending text messages. And then what's that got to be? What inequality am I going to use?
Less than or equal to
Nice, less than or equal to what?
50.
Right. So at most, less than or equal to 50. So here's what we got for our inequality. You guys see that? And then we got our equation. There you go. So everybody with me on how we got to this point? Jaden's correct. Any questions about this? Okay, now we need to go ahead and solve it. What's the first thing we're going to do to solve it?
Minus 42.50 cents.
Right, very good, Alexis. But next time, raise your hand. But we're going to minus 42.50 from both sides. Now, when we do that, just like the last problem, look at this. Here we go. I'm going to put these zeros up here. You guys go ahead and subtract that. Go ahead and subtract that and work that out. So when I have $50 and I subtract $42.50, how much do I have left? There we go, $7.50. Now we got, this became 0. I got 20 hundredths T plus 0 is less than or equal to 750. We can simplify that. And actually I dropped off that 0, right? So you guys see what I did? I got rid of some zeros. Now, how do I isolate my variable? Somebody volunteer and tell me how am I going to isolate my variable. Atisha, how am I going to isolate my variable?
You're gonna 0.2 to both sides.
Okay, and what do we do with that 0.2? Are we going to add it, subtract it, multiply it, divide it? What are we doing? Well, what's happened between t and 2/10 right here? What is that?
Oh no, you're dividing.
Right, that's multiply, so we got to undo that. We're going to divide both sides by 2/10. Very good. Okay, now, you guys go ahead and work that out. Remember when we do long division, what we do with our decimals? I'm not going over that right now. And when somebody's got that result, that quotient, tell me what it is. Hey, Kenny, take your head out of your coat. Thank you. Who's got it for me? Noah, go ahead.
The last answer I got was 37 and 5/10.
Right. So, can you send half a text message?
No.
So, what's that going to be for my answer then? No, that's too many. Because then, you see why you don't round up? Because if you bump it up to 38, then she's going to be over budget. So, is 37? Lynn can send at most 37 texts. Okay. Any questions?